In our last video, we learned about methods, and in this video, we're going to learn about a couple of special methods that are built into the Python language that you can build in any kind of class. So this is basically the same code that I had before. You may notice that the yellow dots on the side have disappeared that I had before, yelling at me because I had all of these dot date, dot temperature, dot relative humidity I was using down here and hadn't defined them up above. That's what those yellow boxes in the previous video were about. And I managed to get rid of those by using this built-in class init. Now, when I say built-in, I mean this is a command that or a procedure that you can define, but it has some special kind of functionality. There's two underscores in the front of it and two underscores at the end of it. It's done that way because Python programmers figure that there's no way somebody would define a procedure with that name. You might call a procedure called define a procedure called init, but you probably wouldn't do it this way. So this procedure has some very special functionality, and the functionality is this: anytime that I instantiate a variable of type weather, that init class is going to be called immediately. So when I come down here and declare today to be of type weather, the first thing that's going to happen is, well, some storage space will be set aside for the variable today, but it's also going to call init. And so you can see that with init, I'm passing in or when I declare this is something new. I'm actually passing in variables to weather. And what that means is you're passing in variables not exactly to the class. What you're doing is when you're passing these variables into this init procedure. So in order to do this, to pass variables into the class, you have to have an init procedure defined. And then again, whenever you declare a method, I call it procedure, but a method in a class, you're going to use the self variable. So self in this case, because we're instantiating it with the name today, is really going to refer to that variable. But again, we call it self. So init simply takes the date, temp, relative humidity, wind speed, wind direction, and sets them to the class attributes: date, temperature, relative humidity, wind speed, and wind direction. And notice now that PyCharm is saying, hey, I know what these attributes are now because you've defined them in your init class. Init method. And then other than that, the code here is exactly the same, but notice that this was the old code from the previous video. Notice how much nicer the code down here is. And so I keep emphasizing the idea that the code here is going to be a lot nicer, but we're making the code up here for the class more complicated. And what I'm saying is that's okay, because what's eventually going to happen, actually in the next video, is all of this code for the class is going to go into a module, and this code is going to become our main program. And because we built that class up to have a lot of functionality, our code in our main program only has 2 lines of code in it, and it's pretty easy to read. So this is how classes work. You build up all the functionality inside the class. The class takes care of everything you need, and then your main code is very easy to read and very short. So we can run this, and it prints out the exact same information that we had before. And again, setting the attributes in this case is handled by the init class. Not the init class, the init method. And then, we call print weather again with that information right here. Okay, I'm going to teach you about another one of the built-in methods called the string method. And you're actually familiar with this already. We've encountered a lot of variables in Python where you can call string on them. So I have replaced the print weather method from the previous version of the class. That's gone. and Celsius and wind chill are still there, and init's still there, but I have this new method called string, and very similar to init. Starts with a double underscore, ends with a double underscore. This one I'm only calling with the self variable. And what this does is it returns a string. And the string is formatted to look the exact same way that I had the output formatted before. So the date, the temperature on a new line, relative humidity on a new line, wind speed on a new line. Notice that some of these things are numbers that I have to convert to strings. But then other than that, this thing just returns a big long string. But the neat thing about this built-in method, string, is that it's called automatically by the print command. So now that I've defined this string method, and you can define a string method in any class, again, it's just double underscore, str, double underscore, with a self. You can put this in any class. This string method defines how print commands will print a variable of that class out. So I instantiate today. It will be initialized by the init command to have this date, temperature, whatever are these in, relative humidity, wind speed, and wind direction. And then I just call print today, and the print command will go in and look at that string, str, and it's going to print that. So let's run this. And it looks a lot like what we got before. The formatting I did change a little bit, so now the miles per hour is right up next to the 10, and I removed one line and I made this say wind speed is 10 miles per hour from the northwest. So I put the wind direction and the speed on the same line. Notice that if I wanted to, I could in here add something else like I'm just going to put that this method string is really awesome. That's my opinion. And when I do that, I actually get that printed out. Anytime now that I call print with a weather, a variable of type weather, I'm going to get that. So maybe I shouldn't leave that there. I'll take that back out. But you've encountered this string method before. In fact, we're using it right here. So this is a float, and it turns out float has a built-in string method. And so I could then, if I had a string, I can throw a weather class variable in the middle of a string. I can call the string method on it. So I could down here do something like print Fred. I don't know how I'm just making stuff up. Plus string today. And run that. And there it is, Fred. And then now today has defined a string method. I can't do that over in the previous version of this program. So that's defined through the class. If I tried that over here, I don't know why I'm using Fred, but if I try that here, then it's going to go ahead and print today, but not in a way that we really would like to. What this is saying is, you didn't tell me how to print out the variable today. You didn't give me directions on how to do that. So what I'm going to tell you is that it's an object. It's an object of type weather called in the main program. And, here's the physical address for it in memory. So good luck using that. That's not really useful. So this built-in string command and built-in init command are very useful and very handy. And now maybe you have a little better understanding of what string to a float or init does. Okay, I'm going to show you one more little trick with init. Remember, this is the method that initializes your class variable. So I'm going to do, the problem with the way I have init set up here is that I'm passing in variables to it. But what if I wanted instead to have the user input all this information? So I could do that separately, but it just feels like the class itself should have a way that I can instantiate a variable and then ask the user to input that information. It doesn't seem like I should have to write that code myself. So here's a little trick to do that. Everything else in here is the same. The string method's the same, Celsius, wind chill, nothing else has changed. But I have changed init so that you see this is a lot more complicated. And what I've done is I've given all those variables that I've called default values. And they're all defaulted to none. So now all these variables are optional. And if I don't pass those variables in, then they will default to none. And then what I do down here is I check to see if they're all none. And I debated on whether I wanted to actually check to see if all of them were none or just check to see if one of them was none. And I decided to go with all of them, but that was a choice. So what I'm saying is if these are not passed in, then must be whoever's creating this variable actually wants me to figure out what those values are. So I go out and do the user input right in the init command. So it's going to ask the user to put in the date, to put in the temperature, the relative humidity, the wind speed, and the wind direction. Otherwise, if these are not none, that means that they must have been passed into the init and I just set them as before. So this is the exact same code right here that I had in init to begin with. So let's see how this works. Right here, I'm instantiating today the same way I did before, and it's just going to print today out. And we're going to start a new line. And now I'm calling the weather class again without any parameters or any arguments. And when I do that, again, my init command up here, init method, is going to say, oh, you didn't pass any of these variables in? What is this thing yapping about? You must want me to input those. So it's going to ask me to input the second instantiation. It's going to ask me to input tomorrow. All right, so let's see how that runs. Okay, so again, it's printed out the values for today, and then it comes down to tomorrow equals weather, and I don't pass those variables in, so they default to all their values are none. So it checks that if statement and says, oh, all these values are none. I am going to do the inputs. So let's see, it is 11, 19, 20, 14 right now. Temperature is really cold. I'm going to go with -3. I have no idea. Relative humidity, it's kind of dry. It's cold out. Wind speed, 200 miles an hour. That's what it feels like. It's nowhere near that. And it's coming from everywhere, but I will say it's coming from the northwest. Just to be done. And then immediately afterwards, we call print tomorrow, and of course it has all those values in it. So if you set up the init correctly, you can have it so that you can pass in values that you may have gotten from somewhere else. Maybe you read them in from a table or who knows what, or you can have the user put them in. And again, I'm focusing on, look at the functionality down here. The programmer that's using my weather class really doesn't have to work very hard to use it at all. Mm-hmm.